Okay, today we're starting Chapter 10, Section 5. We're going to be talking about systems of inequalities. And first we need to know how to graph an inequality. Alright, so we begin by considering the graph of a single inequality. We already know that the graph is y is equal to x squared. It's a parabola. So if we replace the equal sign with a symbol of greater than, we obtain the inequality y is greater than or equal to x squared, as we see in the figure. Its graph consists of not just the parabola in figure 1, but also every point whose y-coordinate is larger than x squared. We indicate the solution the solution in figure 2a by shading the points above the parabola. Okay, so let's look at the next page. Similarly, the graph of y is equal to y is less than or equal to x squared, which is in figure 2b, consists of all points on and below the parabola. However, the graphs of y is greater than x squared and y is less than x squared do not include the points of the parabola itself, as indicated by dashed curves. Okay, so that was a lot to unpack. Let's see if we can unpack that real quickly. Actually, no. Okay, so if I recall, what we're going to have to do is we'll just talk about it, make it seem kind of esoteric, and then we'll discuss why it is the way it is. All right, but starting off, one of the first things that you should be familiar with is notice how. Oh, that's not good. We have dotted lines here. Let's see. Those are unintentional dotted lines. Let's see if we. Oh. Alright, we might just have to draw with something else. One moment. Alrighty, so anyways, back to what I was saying. You should be familiar with the notion of the dotted line and the well, that would be the dotted line, and this is the solid line. The solid line corresponds with the or equal to part, right? Greater than or equal to or less than or equal to, whereas the dotted lines only correspond to those that are strictly less than or strictly greater than. The graph of an inequality in general consists of a region in the plane whose boundary is the graph of the equation obtained by replacing the inequality sign with an equal sign. Yes. All right, so last sentence there. To determine which side of the graph gives a solution set of the inequality, we need only check test points. Okay. So again, like I said, they kind of left a lot out there, but all we have to do is figure out what the test points are. Right. So here are our steps, kind of. They're pretty easy. I think, considering what all we've done in this course. All right. Normally, I don't follow along to these nice, easy, step-by-step things. But in this particular case, it's two steps, right? So number one, we're going to graph the equation. So graph the equation that corresponds to the inequality. Use a dashed curve for the greater than or less thans, and a solid curves for the less thans or equal tos or greater than or equal tos. All right. Once we do that, we're going to graph the inequality. Okay. So we're going to graph the equation first, which basically means we're going to graph the equation as if there is no inequality involved. Okay. So let's go back and just really kind of hammer that one home. Right. So this particular problem, if this were the problem, y is greater than or equal to x squared, okay, we would just start with the graph that we're familiar with. Right. However, now that we graphed, well, I say we graphed the equation we're familiar with. All right. There we go. I don't know why. This pen isn't even electronic. It's just a stylus. I don't know why it's messing up. I don't know. Anyways, let's try this one more time, and then I'm just going to start using my finger, okay? So anyways, y is equal to x squared is basically just what we graph, this graph here. All right, and then once we get to the next point, what we're going to do, so again, literally just step 2, is we're just going to graph the inequality, right? So what we're going to do is we're going to use test points, and if you're got this far, you should be very familiar with test points, right? You basically take the inequality, and then you use a test point to see if that test point comes back true or false, right? And we don't. Right, so right here is important. If the point satisfies the inequality, then all the points on the side of the curve satisfy the inequality. Okay, and of course we will see good old examples of that here in just a moment. Right. And for yours and my viewing pleasure, we're going to have to just snip these because it makes it a lot easier on the eyeballs, I think. Alright, where did I let off? I think I could put that the whole thing there. Okay, let's try that. Oh, that's where my issue was. Okay. Sorry. Because I didn't include the problem. Alright, so now let's do this. We'll put this should fit. Hopefully. There we go. Alright, now if you don't mind, let me go ahead and just go ahead and do all the snipping here so I'm not having to stop in between actually doing the problem. That was not what I wanted. Okay, that should take that. Alrighty, so if we were asked to graph this inequality, we see A is the inequality x squared plus y squared is less than 25. Alright, so you should know this because it is a circle, right? It is a circle centered, it looks like at the origin with the radius of, with the radius of 25. I'm sorry, with the radius of 5. Alright, so yeah, so it's just a circle at the origin with radius of 5. So what we're going to have to do, and then when we talk about these test points, is we're going to pick a point inside the circle. So we're going to essentially have something like this. And here's our circle. We're going to pick a point inside the circle, and we're going to pick a point outside the circle. And whichever one of those points, when we plug them into our inequality, comes out true, then that's the side that we shade. Right? So let's look down here now. All right, we're going to look at the test points. Okay, so in this particular equation, we're going to use test points 0, 0. Okay, and 0, 0 is really easy to use, right? Because all we have to do is plug in 0 for x and 0 for y. Well, 0 squared plus 0 squared is 0, and 0 is indeed less than 25. Okay, so that part is true. So we could essentially just be done. Okay, but we're going to take it just one little step further, just to prove how this shading works. Okay, so again, since it is true, what we would do is we would shade inside the circle where we use our test point. Our test point in this particular case was right here at 0, 0. So we would shade inside the test point. Okay. All right, but now on this particular example, we're also going to use the point 6, 0. All right. Now, while I'm at it, basically the same thing we talked about before. If you have the number 0 available to you to use as a test point, then use it. Because 0 is super easy to add, subtract, multiply, and divide. All right. So anyways, so we've got, we're going to use test point 6, 0. And when we plug in the 6 for x, we get 6 squared is 36. A 0 for y, well that's just 0. Well 6 squared is 36. And 36 is not less than 25. So therefore, it is we would obviously have just stopped at shading this area inside the circle because the inequality on the outside is a false statement. Okay. Oh, and I made the first mistake. It is a strictly less than symbol, so my circle here should have been a dotted line. So we're just going to erase that, that's the way it is, Right? And of course that would be the better example. Right? Next up, we have the equation up here. X plus 2y is equal to 5. So again, what you're going to do is you're going to start off just drawing the graph of x plus 2y is equal to 5. Right? And when you draw the graph, you're going to get this line right here. Without the shaded area, you're just going to get that line, right? Let's real quickly, let's do this. Let's turn this into an equation that does seem a lot easier to graph. Which, I mean, it's not horrible now because you can just use intercepts, but I like to change my equation and put it into slope-intercept form. So starting off, let's just go ahead and move the x to the right side. So we would end up with a 2y is equal to a negative x plus 5. Right? And then we're going to divide both sides by 2, so we're going to have y is equal to a negative 1/2 x plus 5/2. Okay? And that is what this red line is down here. Right? And then of course we're going to look at test points, right? Well, our test points, I'm sure I looked on accident, but I was going to say I'm sure one of the test points that we're going to use is 0, 0, right? Because it's available to us. I mean, unless your line is going through the point 0, 0, you're probably going to be using it. Okay, and in this particular case, the textbook does use some other number besides a 0 for my second test point, but we could just as well easily choose something like 0, 10, and we're going to actually use 0, 10. Okay. So we're going to use test point 0, 0. And of course, if we plug in 0 into both these points, right, it just becomes 0 plus 2 times 0, which is just simply 0. And 0 plus 0 is not greater than or equal to 5. Okay, so realistically, we could stop there. We really could. Okay, so since we know that this test point 0, 0 does not work, we know that we're not going to shade this downside of the line, and we can just simply shade the top part and be done with it. Right? But let's just take this one little step further. And I said 0, 10, right? So 0 on the x-axis and then up 10. So the point's going to be up here somewhere. Let's see. Little minute movements aren't the best for this particular program. All right, so we're going to be plotting that point up there. Okay. Well, we plug in a 0 for x and a 10 for y. Well, 0 plus 2 times 10 is 20, and 20 is indeed greater than or equal to 5, so we would shade on that side. So we would shade on this particular side. Again, it doesn't matter which way you get there. I mean, unless I'm mistaken, you don't have to check both sides. Not for single problems. For the systems, which we're going to get into, yes, but not for these single problems. You can just check one side. Does it work? Then shade it. Does it not work? Then don't shade it. All right. Next up, we have I guess what this chapter is called, right? The systems of inequalities. Okay. So systems of inequalities is just a little bit more. But realistically, we learned everything we needed to just then, right? So when I say a little bit more, what I'm talking about is these problems, instead of having one equation, we're now going to have a system. So remember how I spoke about how piecewise defined functions are kind of cheating, right? They're cheating in a sense that, it's one problem, but it's a couple problems, right? It's like a 3-question quiz, but each question has 3 parts. That's 9 questions, right? So that's kind of what we're just stepping into, right? But anyways, a system of inequalities. We now consider systems of inequalities. The solution set of a system of inequalities in 2 variables is a set of all points in the coordinate plane that satisfy every inequality in the system. The graph of a system of inequalities is the graph of a solution set. Okay, so you know what? That's just a lot of math words. Um, it is pretty much exactly what you think it is. It's a bunch of inequalities. We just call it a system. All right, so let's go ahead and jump down here. We'll use the pen for this. Okay, so the solution of a system of inequalities. So it's basically what we did a second ago. Okay, except now there's a third step, and that's find the vertices. Right? It says label the vertices of the region that you shaded in step 2. That's really it. So besides that, it's exactly what we just did a moment ago. So let's get started on that. I believe the next problem is right underneath it. I wonder if it's my sleeves messing this up. Nope, not my sleeve. Alright, it's gonna be just another thing that, you know, it appears hand wavy, but you know I'm not like that. I don't know why in the world this pen ain't working. I say that because I did have a pen. It was a Bluetooth pen, and I could see how that wouldn't work, right? I mean, my Bluetooth is finicky, especially you know like on a laptop or something. But this one is not even a Bluetooth. Okay, we're gonna have to make that a tad smaller. Okay. Alrighty, so this reads, graph the solution of system of inequalities and label its vertices. Alrighty, so just like on the previous example, as a matter of fact, I think this is a combination of both of those examples. X plus 2y, is it? Yeah, it's a combination of both. Perfect. Huh. Well, I'll be. Alrighty, so now we see that the system again is just kind of like the cheating form of the, you know, oh gosh, I just said it. Piecewise defined functions. Right. So we know what it looks like and how to graph them. Right. So looking right here, so it reads, in figure 5a, we graph the solution of two inequalities in the same axis. Alright, so we graph them in different colors. Obviously, right? The solution of the system of inequalities is the intersection of the two graphs. Alright, so notice how if we just straight up graphed both of the inequalities as we did in example 1, we knew that we shaded outside of the no, we shaded inside of the circle and above the line. Right. So in this particular case, since this is a system of inequalities, the shaded area will be where those two shaded areas overlap. Okay, and they overlapped right here in this region. All right, maybe I should have used. Well, I don't know. I don't know if green will work. Yeah, green will work. All right, we shaded right there in that region where they overlapped. Okay. Next up right here, it reads, find the vertices. The points -3, 4, and 5, 0 in figure 5b are the vertices of the solution set. They are obtained by solving the system of equations. We solve the system of equations by substitution. Solving for x in the second equation then gives, solving for x in the second equation gives x is equal to 5 minus 2y, and substituting this into the first equation gives, and as we see down here, we end up with, let's do one more down here. As we see, just doing the algebra that we've done in the first two sections of chapter 10, the points 5, 0 and -3, 4. Right. So note that in this case, the vertices are not part of the solution set since they don't satisfy the inequality. They simply show where the corners of the solution set lie. Okay, let's see if we can show that. Okay, and it does have them pointed, right? So these points indeed are not part of the solution set, but they are, as mentioned, simply the corners of the system of inequality. Okay, and that concludes the lecture. Well, that problem.